So for our power law, we're going to learn two parts to it. This first part, we're going to look at a power to a power. That's what it looks like in part B and C. Now, in order to figure out what a power to a power does, we can write things in expanded form. So for example, 2 cubed means 2 times 2 times 2. What does 2 squared to the power 4 mean? Well, which power would you like to talk about first? Let's say you decide you want to talk about the exponent of 4 first. What does it mean then if I have 2 squared to the power 4? It means that I have 2 squared times 2 squared times 2 squared times 2 squared.
You want me to write that all down?
Yes, I want you to write that down. Then, if we talked about the exponent 4 first, then next we have the exponent 2 in each of these, and that'll mean 2 times 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 2. How many 2's is that in total? 8. So this one is equal to 2 to the 8. Your job is to see if you can figure out a pattern so that this is shorter. You could also write this one in expanded form. You could also write this one in expanded form if you dealt with the exponent of 2 first. So if I did the exponent of 2 first, that would be 2 times 2 to the 4. And then if I thought about the exponent of 4, that means 2 times 2 once, 2 times 2 twice, 2 times 2 a third time, and then 2 times 2 a fourth time. How many 2's are there? I still get 2 to the 8. What's going to happen with my x's? Which exponent would you like to talk about first, the 3 or the 2? The 2. So that would mean I have x times x cubed. Then if I talk about my exponent of 3, that means I have x times x once, x times x twice, and then x times x a third time. How many x's is that?
8.
6 of them. Now, you can always figure things out by writing it out in expanded form. However, sometimes it might take a lot of space. Can you imagine if I did part D here, and I said, I have 3 to the 7 9 times? Can you imagine writing 7 3's and then doing 7 3's 9 times? How much space would that take on your paper? A lot. So how can I know to do this right away? We multiply the 2 exponents. Can you see that here? 2 times 3 is 6. Can you see it in the first one? 2 times 4 becomes 8.
Maybe you could have just told us that at the start. That would have been so much easier than writing all this down.
I could have just told you that, but if you don't see it, you won't know why it works. So we can write this power law like this. When a power is raised to another power, what do? We multiply the exponents. Yes, I can go back. All right, try these ones. We'll go back for a second. So if you get stuck, you can always write things in expanded form. And sometimes when I get stuck, I decide, oh, I don't want to write it out in expanded form because it takes so much space, but I just imagine it in expanded form, and then the rule comes to me. So for this first one, I imagine 4 5s 5 times. And I said, well, that's a lot of 5s. And then I remember, oh yeah, this is the one where I have to multiply. What's 4 times 5? 20. And that's the simplified form. We're not going to evaluate this because if you try to put this into your calculator, it's going to be such a big number that it won't even fit on your calculator screen.
Do you have to put the bracket on it?
No, you don't need brackets on it. So this one, if we multiply these together, we're going to get 2 to the
-6.
-6. And this one, if we multiply a -4 and a -5 together, we get
20.
+20. Yes?